Hello, everyone. Welcome. Welcome to our FabFems Friday webinar with the focus today on STEM in air and space. We have a fabulous lineup throughout June and July, and we hope you can join us weekly for panel discussions with current students, alumni, and STEM role models from our community. I am Tonya Taiwo. My pronouns are she, hers, and I'm with the Women in STEM within the Division of Diversity and Community Engagement at the University of Texas at Austin. Today we have Joyce Atucci helping us with the Q&A portion of our webinar. You can find many of our FabFems Friday panelists and more amazing STEM role models in the FabFems directory, a national database of women in science, technology, engineering, and mathematics professions who are inspiring role models for young women. The FabFems directory is managed by the National Girls Collaborative Project and is designed to help increase career awareness and interest in STEM. STEM role models can create a FabFems profile and indicate how you want to be connected, either just serving as a role model with your profile online so students can read about your experiences, or volunteering to be contacted via email or other options. Students, you can search by adding a keyword or a variety of other factors such as zip code, field of work, ethnicity, or interest of engineering. There are lots of options. Joyce is going to go ahead and drop the link in the chat for you all. We will be adding all of our FabFems Friday webinars to our WeSTEM YouTube channel and other videos to help future and current students. Subscribe to the channel to get notified when new videos are added. Joyce will also be throwing this link into the chat so you guys can go ahead and subscribe. So today our focus is on STEM in air and space. We will have each panelist share some quick introductions here in a moment to get us started. After these introductions, we'll have a facilitated panel with some pre-selected questions. We'll also be taking questions from you all, so use the Q&A area to submit your questions at any time. I'll give the floor to you all to go ahead and introduce yourselves.
All right, I can go first. Hi, everyone. My name is Pam August. My pronouns are the same, she, her. I'm from Spring, Texas, and was an aerospace engineer at UT. Got my bachelor's of science there. I work at NASA's Johnson Space Center in the Flight Operations Directorate. And just a little bit about me, when I am not at work, I am spending a lot of time with my family or listening to music and reading. It's nice to be with y'all today.
Good morning. I'll go next. My name is Carrie Stanley, and my pronouns are she and her. I'm originally from Fort Worth, Texas, and went to the University of Texas for my mechanical engineering bachelor's degree. I currently live in Colorado and work at Lockheed Martin Space. And I graduated in 2010. Let's see, in terms of hobbies, I have two young sons, 2 and 4. So my world kind of revolves around them right now. And I'm really excited because we're starting to get into sports. So that's taking up a lot of our time, seeing what kind of sports they're starting to get interested in.
I can go next. Hi, my name is Angela Bose, and my pronouns are also she, hers, and I work at NASA Langley Research Center, which is in Hampton, Virginia. I'm originally from the Washington, D.C. area, and I have a bachelor's degree in aerospace engineering from Purdue University and a master's in aerospace engineering from UT. Let's see, in my spare time, I also have 2 daughters, so as Carly had said, the world kind of revolves around them at this point in time. They're older though, so they're in a lot of activities, and as I also enjoy traveling and hiking. Thank you for having me here.
Hi, everybody. I think I can wrap up the introductions for us. My name is Jessica Voss, pronouns she, her, And I was born and raised in Alaska, and then went to UT Austin for my bachelor's in aerospace engineering, graduated in 2002. While I was there, I did the NASA's internship or pathways program where I went back and forth each semester, and eventually landed a full-time job at Johnson Space Center in the Crew and Thermal Systems Division. And I've been here ever since. It's been almost 24 years now, and I'm now supporting the Safety and Mission Assurance Directorate. I have two kids as well, a girl that's 14 and a boy who's 10, and he's really excited about his School of Rock drum rock show later today. And from my hobbies, I really enjoy travel and hiking as well.
That's amazing. Thank you all for your introductions, and thank you all so much for being here. So let's get started with the facilitated Q&A portion. Let's hear a little bit more about each of your career paths. Can you each share how you chose your major and how you got into your current position?
I can definitely go first. So I didn't mention before, so my current position, I'm in a detail role actually with the Langley Future of Work team, but my background is in mission design, introductory design, so literally designing how you go from one point to another. I did that at JPL, originally at the NASA Jet Propulsion Laboratory, so doing interplanetary, a lot of work going to Mars. And then here at Langley, my home area is the atmospheric flight entry systems branch. So I do trajectory design around returning back into a body and the path that you would follow coming back in. And in my current role, I'm kind of applying that same kind of thinking of how you get from point A to point B and what are the implications of the paths that you take to all the other systems that are involved, so that you can choose the best path. To how we work in a hybrid world, how NASA should be in the future, as we're kind of the paradigm of everything has shifted. And so it's been kind of a fun role to be in a detailed position. That's a temporary role that we can do at NASA. And I've been in that for the past 14 months. I actually wanted to be an astronaut. And so that was kind of what led me into this. And so when I was 10, the Challenger exploded, and strangely enough, that's what really solidified in my mind that I wanted to be an astronaut, which is kind of a weird way of having that happen. But I begged my parents for years to let me go to space camp. I don't remember how I found out about it, and they it was too expensive, but they finally did let me go, and I credit space camp actually for kind of showing the different pathways to becoming an astronaut, and engineering being one of those. So I wasn't really sure engineering was for me. In high school, I was debating between that and music. I play flute, and had a lot of people telling me I should go down the music path, but I felt from a practical sense that getting an engineering degree would open a lot of different doors. And what I found is that it actually does fit me really well because I love to solve problems. So.
We're all too nice. We're obviously from Texas, Pam. I'll go next. So as I said, my major was mechanical engineering. That was also in high school. I did not want to do mechanical engineering. I thought I'm going to do anything other than engineering. I had a father who had grown up doing mechanical engineering and had fallen in love with airplanes, and it had kind of been shoved down my throat all those years. So I said, anything but that. And what I really wanted to do was go into the business side of things. And I remember talking to mentors at the time, and they said, okay, but what kind of business? And I asked myself, well, what do I want to go build? If I were to go build and sell something, and airplanes was actually something that was interesting to me. So ironically enough, I went into that's why I decided to go into mechanical engineering. Mechanical engineering too, I loved because you can do anything with it. So it didn't just obviously have to be airplanes, that I could have gone to space, which is where I ended up landing. I could have gone into the medical field or into cars if I wanted to, etc. So I went into mechanical engineering, and my internship during college kind of landed me into the space division at Lockheed. So I didn't know it's something that I wanted to do until I started actually working with spacecraft. And I was very fortunate to have that literally hands-on experience with space vehicles through those internships. And that's where I really fell in love. Like the idea that I was touching something with gloves that would be going into space was just amazing to me. I am now a senior program manager at Lockheed Space, and I am a program manager of a program that I can't talk about on the unclassed side, but I've worked many programs that I can talk about. So that's what I hope to do with you here today. But I have not been on the deep space side or the side that maybe the NASA ladies here will be talking about, but more the communication side of spacecraft. So I've worked on both commercial and military communication satellites that create that comms network that you need, especially when your ground networks may go down, your terrestrial aspect of talking on your cell phone. So that's where I've landed now.
All right, I'll go next. So I was interested in space ever since I was a little girl, and I knew I wanted to work at NASA even just as a little girl. So I always loved math and science. My dad was an engineer, and so I just kind of figured that was a good path for me, and picked aerospace engineering. But like Carrie is saying, mechanical engineering would have been great. There's a lot of different engineering fields. What the kind of work we do in the flight operations directorate, so that is basically all the flight controllers and the astronaut trainers that are supporting the crew on their human spaceflight mission. So I was a flight controller sitting in mission control with the headset. I did years of training to even be certified to be able to do that, and did that many years. And now I'm in a leadership position, kind of managing a team. So in terms of how I got to where I am, honestly, some of it is luck. I knew I wanted to be at NASA and just started applying for things and sort of just ended up here in flight operations. And I just absolutely love it. The work is so exciting. It is incredible to be able to, I mean, I've trained astronauts, I'm friends with them, I'm in meetings with them every day. So it's a really direct link to the mission, right? There's so many aspects of supporting human spaceflight that's incredible, from designing things to testing things to where I am, which is operations, which is kind of, we call it the tip of the spear, right? You're there doing the thing that we have all been planning to do. And it takes that huge community to all make it happen, but it's just a really exciting phase of it. So, I've just kind of worked my way up into new roles, which if there's time I can talk more about, but I'll stop there.
It really is exciting to hear how each of us kind of landed where we are. I, being born and raised in Alaska, had a lot of time staring at stars and planets, and it just so happened that while my parents did not go to college, I was the first one in my family to graduate from college. They were engaged, they were pilots, private pilots in Alaska, and they eventually worked as air traffic controllers for the FAA. And my dad was really smart and eventually did get an associate's degree in some sort of computer programming. I'm not sure exactly which kind, but he was engaged in a lot of really interesting projects on the FAA side from coding. And at home, we had a garage that we didn't park the cars in because my dad's giant telescope had to be there instead. And we would read an article in Scientific American, and there was no internet back then. So it was like, we're reading these magazine articles and I'd ask questions and he'd be like, let's check it out. And he would set up the telescope and we would look for it. And we just lived in a nice enough remote area where there wasn't a lot of light pollution and we could check this stuff out. So to me, when I was graduating high school, and I won't say I loved math and science, but I could do it and I understood the value of it. I said, well, if I'm going to do engineering, I'm going to pick something that's really, really cool to me. And I was aerospace. I will say, when I started in aerospace engineering and I really got, dove into those classes and started to learn what all of the material associated with engineering was, I started to question whether or not I had made the right decision for me. And it wasn't until I was able to start working as a co-op at Johnson Space Center to realize, oh, this stuff that I'm learning in the textbooks is theory, and it can be applied in a really cool way. And in my case, it was in life support systems and spacesuits. So I spent the first decade of my career here in the EVA world, working on advanced spacesuit technology development. I was in the advanced spacesuit lab, and we did really cool testing and coming up with really innovative ways to understand human performance in a spacesuit. I forgot to mention that my master's is in fitness and human performance from UHCL. And so I have a whole side life that is fitness and exercise instruction and stuff. So for me, it was a awesome blend of like two of my favorite things, space and human performance in spacesuit design. So that's what got me there. I since moved into more of like a systems engineering role across the entire vehicle, starting with the cockpit of Orion, which is the next spacecraft taking the crew to the moon. Artemis 1 was the first demonstration test flight of that, which did not have crew in it, but Artemis 2 will next year. And so now I'm in the safety and mission assurance role for which covers it's called project lead engineer. That's the name of the position, but it covers all of the systems that have to do with this crew and service module and the launch abort system as well.
So before we move on to the next question, I just want to reiterate that there's no one way to reach the job that you want in the future. As we see from all of these panelists, there's different ways to do it, and it's not going to be a linear path. So just remember that.
Very, very true. Thank you all so much for sharing. That was absolutely fascinating. So let's dive deeper into your STEM work in air and space. Can you tell us about a specific project or product you've worked on that can give our audience kind of a glimpse into your day-to-day STEM work world?
Yeah, so I can start. I think I might be an outlier here a little bit. So the comm side of things, because I know I also I didn't even think about this aspect of spacecraft before I fell into these sorts of opportunities. So to give an idea, I've worked on a couple programs that I can talk about. One is a Japanese program where it was a commercially provided spacecraft and ground system that we provided to Japan. That customer was Docomo, which is the equivalent of AT&T, kind of like an equivalent to AT&T here. And what we were doing with those spacecraft and the ground network was, and it was only one spacecraft in this particular situation, was creating basically an antenna in the sky that could transmit and receive signals, think RF, like your cell phone, to their cellular network on the ground. And it would be able to help them if a hurricane happened and they lost their terrestrial ground network that they relied on for the typical cell networks that they use from a day-to-day perspective. Some of the interesting aspects of that was the RF engineering that went into it, because when we provide spacecraft to our commercial companies out in international areas, we do not do any sort of security around the communications that we're giving them. And so the antennas that had to be designed gave all the sort of power in that RF frequency right where they wanted to talk, but it quickly sloped down when you look at that beam, disseminated when you got to the neighbors that Japan has, that data would only be provided to Japan. From a mechanical perspective, you have to create these spacecrafts that once they're in the orbit that they need to be in our case, for comms, it's GEO, because you just want it to sit there and not move. You don't have a lot of, at least mechanical dynamic environments that you're dealing with. You build and design this spacecraft to be able to really survive the launch loads that it's going to go through in the rocket to be able to get to that place in its constellation. But even once it gets in that GEO environment, you have to take into account the environment the thermal environment, the radiation effects that it's going to have, and be able to survive that. And you have to think about the packaging of those antennas, think really big RF antennas that need to be able to unfurl and provide the receive and transmit required once it gets into space. So if that helps, my best role ever was being the mechanical system engineer, which basically meant I was the tech lead for the mechanical system on spacecrafts like that. And being able to literally watch it from design to build to testing like it was going to fly on the ground, putting it into the rocket that was going to launch it into space, doing the final inspections, and then stepping out of that rocket and then seeing it actually be able to work from space was amazing to me. So anyways, that's one example of how I use my mechanical background and what it looks like.
That's very interesting. Thank you for sharing.
I feel like I could follow you, Carrie, because some of the work you do kind of feeds into some of the type of work that I do. So the process that she was describing of, how a mechanical system gets designed and then gets tested and built plays into the roles that I've had, because oftentimes the mission design has to flex in order to accommodate the designs of the mechanical components. And so a lot of the work that I've done is the type of analysis when she's talking about, something being able to design, unfold and have the right sun angles. That would be a type of analysis that we would understand is the orbit that something's going to be in sufficient to give it the amount of light and power that it needs for other subsystems. So that's one aspect of it. A couple projects that I've worked on, I've been really fortunate in my career to work a lot of different flight projects, and they've all been different in terms of my role in them, other than I've still been doing, this type of mission analysis or trajectory design. So for the Mars Reconnaissance Orbiter, I helped design the primary science orbit. There are 8 different science instruments on that payload, and so they all have very different competing needs to get the science that they want. So some of them wanted to fly over, certain spots at certain times of day on a repeated basis. Others wanted to be able to see the entire planet. And so trying to design an orbit that would meet those competing needs was really challenging, especially with 8 different instruments on board. So that was a really fun and challenging project that I did. I've worked here at Langley on some projects that are testing parachutes that are meant to be flown at Mars. So you test them here on Earth at high in the atmosphere in order to kind of reach the same kind of atmosphere and environmental conditions that you would experience at Mars. And so there's been a couple different ones that have been done on sounding rockets that we've done it. Another one that they actually launched from Hawaii up on a weather balloon and then fired a Star 48 rocket to make it go the speed that it wanted to before it deployed decelerators. So there's supersonic decelerators, there's hypersonic decelerators, and then ultimately tested a parachute. So I've worked on some missions there where you have to figure out what is the trajectory that you want to fly on for the test to meet the right test conditions that they actually want it in order to qualify the equipment that you're working with. And then also in those cases, like being able to predict where the spacecraft is going to come back down. So these were things that landed either in the Pacific Ocean or in the Atlantic Ocean. So you have a recovery operations. And so just being able to predict where that would be and predict it with a level of certainty that there can actually be a boat, that can go and get there in a reasonable amount of time and get things up out of the water before it sinks. That's some of the type of the work that I've done. So just to give you a flavor of that, it kind of felt like it tied into what Carrie was saying.
It definitely did. I really love how Carrie's, I guess, explanation of being there from like the design process all the way to seeing the project come to fruition. Like that was very interesting. And then Angela, you mentioning how, I guess it seems like there's like a lot of problem and solution, a lot of testing and verification that goes on in your work. And I think both of those explanations were both amazing. So thank you both so much for sharing.
Okay, Jessica, do you want to go? You keep having to go last.
I was thinking that mine might be a good fit in between what they just spoke about and then your flight ops.
Let's do it. You go.
Okay, so yeah, I really am kind of the go-between. As I was listening to what was being shared, I've often described my position as I get to design, build, test, and operate everything before the astronauts do. So everything that is necessary in a spacecraft for the astronauts to have a safe and healthy and productive mission, uh, I design that. My teams work on that, and they're making sure that they have everything they need. And that starts from the engineering phase of, early prototyping and testing, and then failing and trying again, and till we finally think we've got something that'll work. And then we bring the crew members in and say, hey, what do you think? And they test it out. And of course, it's still wrong because they always have brilliant ideas and they've got space flight experience, and they tell us, hey, in space, this was really going to work more like this, or I would really be in a body position that's more like this. And so can we play around with that a bit? So that's what my role for quite some time as the crew systems lead engineer on Orion consisted of. So designing, building, testing, and operating everything the crew needs inside the cabin, so that they can have a successful mission. Several examples of really, really cool integrated test activities that we do involve not just having a mock-up here at the Johnson Space Center. There's a space vehicle mock-up facility where we have our Orion mock-up there. And we run through kind of day in the life scenarios, or we do like form, fit, function kind of checkouts with different ideas in the mock-up. Everything from that to full on integrated, simulated, emergency egress. And we can use other facilities here at Johnson Space Center and at Denver in Lockheed Martin's ITL Integrated Test Lab, with the software feeding into the sim and the exercise as well. We sometimes use the NBL, the Neutral Buoyancy Lab here at Johnson Space Center. We'll do our surface operations for what if the crew had to self-egress post-landing for one reason or another, right? The spacecraft is no longer habitable. What would we do? And what is also really kind of neat is, since we're here at Johnson Space Center and we have a whole nother program called the Human Research Program, we have a test subject like selection pool that you can be a part of. And so I have, for many, like 20 years now, consecutively been a test subject for all kinds of experiments, including my own. So I've been in pretty much every single spacesuit we've ever had. And I've been engaged in these test facilities where, flight analog facilities, whether it was the Vomit Comet, the C-9 aircraft, or back in the day, it was the KC-135. The NVL surface ops, I've been doing that and met several times in the mock-up. So to me, it's really hands-on engineering. Yes, there's a lot of documentation and presentations that go along with the work that we do, and then writing down the ConOps associated with each of these activities and events and how things are supposed to play out and the actual procedures, and then of course test reports and publishing later. That's all part of it too. But to me, that's the real understanding of how things are supposed to work and how they nominally are going to go, and then what we've got in place to make sure the crew can stay safe if something goes off nominal or a contingency situation happens. That's the exciting part for me.
Thank you so much for sharing. I absolutely love how your role definitely is that intersection between like human-centered design and engineering. It's very interesting.
All right, so I'll share about a project I worked on that was one of the highlights for me. So for those of you who don't know, there's this big, huge International Space Station with all this different partner support that is up in space right now, flying. So back when I started in flight operations, we were still building the space station and adding new modules to it. And I actually got to be the lead on my team for this cupola module. And to tell you a little bit about the cupola, which you should Google because it's amazing, it's the crew's favorite place to be because it's the windows. It's an observatory. So it has 7 windows and it faces the Earth. So there's all kinds of beautiful imagery you can go online and search for when you search for ISS and cupola. So what I did I was a mechanical flight controller. The operations support officer is what our discipline was. I was in charge of basically helping activate and get this thing installed, activated and set up for use. So I wrote all the procedures that the crew executed to basically get it up and running. My team operated the mechanism that attached this cupola module onto the rest of the space station. We drove the bolts from the ground. And then once we got it pressurized and the crew opened the hatches, they would run my procedures to basically get it outfitted. So I trained the crew, I wrote the procedures, I worked with them. And after I remember a day or two after we had it installed, they opened the shutters for the first time, and they actually gave me a call down and said, thank you for all the training I had given them. So really incredible moment to be a part of. So one of the things I love so much about flight operations is you need this core engineering foundation, but you come here and you learn how to be a flight controller, you learn more about the vehicle you're controlling, but it's also this wonderful mix of that core engineering knowledge, but what I'll call soft or people skills, right? You have to be a successful flight controller, your communication skills matter. It doesn't matter how smart you are if you can't communicate clearly and concisely in the flight control room. There are situations we train for that the crews in the vehicle, it's a life or death scenario that we have to be able to clearly communicate to the flight director, this is what I need to do. I need to run this procedure and get it in a safe config immediately. And the comm has to happen very smoothly. So you need good communication, your teamwork, your decision making, your problem solving. All of those soft skills really matter and make or break people as flight controllers.
Thank you so much for sharing. And I love how you emphasize the importance of strong communication. I feel like there's a stigma here in university that STEM students absolutely suck at communication, but as you can see, it's imperative to have good communication in the STEM world. So now we're going to move on to the next question. Do you have any recommendations or words of advice for current or future STEM students who are interested in STEM in air and space?
Can I actually go first? Because I want to elaborate on the comment I just made. So the soft skill stuff. So first of all, get involved in clubs. These design, build, fly teams or nano satellite teams, like get involved in that stuff. That stands out on a resume, and they're a great experience for you. You know, all the, UT, all these different schools, they have there's a great place to go and learn engineering fundamentals. But some of this other soft skill stuff I'm talking about, like decision making and, oh crap, our design didn't work, what do we do? That stuff you can't teach in a class. You need to learn it through experience, through internships, through being on these clubs. So get involved and go learn those things that you can't really necessarily learn in a lecture hall. That's what I would say.
Thank you so much for that.
I'll go next. So I totally agree with what Pamela just said. My first year at the University of Texas was like a shocking year for me. And I'm sure that's, pretty typical. And I thought I had everything figured out because I had taken so many AP classes in high school. And I used to go into high school at 7:30 to take multivariable calculus. So I was like, I got this, no problem. And I went into that first year of school and I just was overwhelmed because it's not just about the academics, it's about every new aspect that you're getting bombarded with in your life, stepping out of that cocoon, whether you realized it was one or not, as you go into your college experience. So I had a dip in my GPA right out of the gate. And I was asking myself, wow, am I even right for engineering? Am I as smart as I thought I was? Because it doesn't feel like it right now. What I'll say is what really helped me was getting involved in the clubs like Pamela was talking about. So reaching out, and it wasn't engineering, by the way. Like what I actually needed was not to have more involvement necessarily with a robotics club or even SWE. I hate to say this, like during that moment, I needed to step out and connect with people outside of engineering. So I actually joined Alpha Phi Omega, which is a great fraternal organization, community service organization. And what that did was also like snap me out of like colleges and everything, like snap out of the bubble, you know, like there's a world outside of here. How are you helping the world outside of here? And then what that gave me was that perspective. It's not all about the university situation right now. There's a bigger why here. And I know somebody asked about the why, but how is what I'm going to do going to help the environment, the world, whatever that future customer is, how am I going to be helping them when I step outside of here? And that's why I'm learning all of this. That for me, that was why I was learning all this. I want to go create products that help someone in some way. And then that helped me really hone in on the focus that I needed. So it was amazing to me that that first year that I actually wasn't doing as much outside of school, that I was doing worse at school. And then it was once I added in not only APO, but I volunteered in the research lab in the mechanical. It was actually technically, I think, biomed, but I was helping them like with cancer cells because there was a professor doing research on cancer cells, which was total. I was a mechanical engineer. Like, why am I doing that? I don't know. It was something else to get just hands-on experience and see, do I like it? It was doing the freshman interest groups, the FIG organization, which I don't know if they have it anymore, but like doing FIG mentoring and leading groups like that. So it was once I added all of that and got that sort of perspective and context that I actually started doing better at school too, for whatever reason. And then it was going out and doing the research, and you're doing it now. You've been listening to panelists about what are the different companies out there, what are the different, for me, it was products out there that I would want to be a part of. And going in and reaching out, and the University of Texas has tons of opportunities to talk to companies, whether it's through panelists, through expositions, and hear from them, and then decide on, you know, what are those companies that I'm interested in maybe being a part of in my future, and how do I get my foot in the door? And that's the other thing I just want to help everybody with, and I know I'm talking a lot, is you may have a dream job and you may not. If you have a dream job, don't think that you have to shoot for the dream job right out of the gate. Don't think that if you don't get the internship, that's that exact job that you have failed. Get your foot in the door. That's the first step. Just get your foot in the door. My first internship was being a database person that I had no interest in, but then I was in, you know, so be willing to do things that may not be totally aligned, but is the first step to getting there.
Very true. Any experience is good experience. That's what my professors always say. Thank you so much for sharing.
Yeah, I was gonna follow up with what Pamela and Carrie had said a little bit, like definitely on the experience, just not saying no to certain experiences, even if you're not sure what you're going to get out of them, because you will get something out of it. And even if you're learning, hey, this isn't the right thing for me, that's valuable to know about yourself because it helps to tailor you on a path that you do want to go down. And you never know where certain experience might be able to be leveraged down the road in ways that you just can't imagine. So keep that in mind as well. But definitely, you know, Carrie was saying, you're gonna fail a lot, so that would probably be my advice. Like, don't just fail forward, and you're gonna have to pick yourself back up and just keep going. And like, especially in this role that I've been in the past 15 months, I've had to stretch myself in a lot of different ways, even at this point in my career, and do things that I'm really uncomfortable doing. And I have felt like an idiot a lot of the time, and just had to kind of put on a brave face and say, okay, I'm learning, I'm doing this, and I'm sure I don't appear as much of an idiot to other people as what I feel like inside. And so just being able to kind of have that compassion for yourself and know that you're in the process of learning, and that kind of keeping your eye on the end game of what you're trying to do as a way to keep moving forward, even as you're going to have some setbacks and failures along the way.
That is very, very true. Always remember to fail forward.
Yeah, I agree with that for sure. It's in my mind, I even want to like remove the term failure altogether, because how do you know what winning would have been like for you? And maybe you did win, right? But the failure is against some other definition or somebody else's expectation, when in the end, just you having had the experience and having stepped out of your comfort zone and saying, I'm going to try something new, you won. You tried something new, and that's never going to result in something that was a detriment to you as an individual, and how you might utilize that experience later in life. So you fail forward or just win every time. Is what I would say. I did a lot of that in when I was at UT. I loved hearing people share that, at college, the coursework, the engineering curriculum is not easy, and it's not intuitive for most of us, right? Maybe some people walk in and they're like the Mozart of aerospace engineering, but not me. I had to work really hard and study a lot. And there were many times where I was questioning my ability or my talent and myself, and wondering if I was in the wrong place. And if I'm so grateful that I did have really awesome friends to turn to, especially since my family was in Alaska, like 5,000 miles away. And I also kept up my kind of fitness side world. Even while I was at UT, I worked at the gym. And I also helped out with some mentoring and supported volleyball games that were going on at the gym, and just to have something that was a completely different community, but still be very actively engaged in that. I was also taking, I just remembered this, that I was taking some of the, what do they call them now? It's like the non-curriculum related classes that you could take at night. And I was taking a dance class. I would just go and learn funky routines for no reason. It was no reason other than just to have a little fun, be with a different group of people, and maybe get some exercise in. That all of that, not at the time, I probably would not have known enough to call it like self-care, or just recognizing that I as an individual was multi-talented, right? I would have never said that about myself. But the truth is, we all are. We all have so many capabilities, and we chose engineering for a certain reason, and you're definitely capable of doing that and a lot of other things. And I'll say that for me, when I did end up getting selected to be a co-op at NASA, I had no idea that would happen. I was competing against the Mozarts of aerospace engineering, in my opinion. And I looking back on it, I still talk to the guy who hired me in the end. His name's Bob Musgrove. And conversations later, I started to recognize that what they were looking for, and they look for this in the astronaut community as well. I've never tried to be an astronaut. My eyes can't cut it. But I've learned that it's a very similar technique in they want well-rounded people that can show up and be the role that's necessary at the time. So if you're not the designated leader, but they need somebody to step in and do some leadership stuff, you learn that by being engaged in all these community things that people are sharing. And they also look for people that are multi-talented and think in diverse ways and have diverse experiences. They're not necessarily looking for that straight A textbook, super smart, genius. They're looking for people that can assimilate information and make real-time decisions that are smart and that are rational and that can think level-headedly even in stressful situations. And I'll say one of the things that I think contributed largely to me being selected at the time was I had just returned I was an exchange student in Russia in my senior year in high school. And so here I was my sophomore year in college, and he saw that on my resume and was like, tell me more about this experience. And I was just like, oh my gosh, it was everything. It was scary and it was amazing. And I didn't know how to read or see or speak to anybody, at least not to the extent that, that Russian student who then came to live with me in Alaska could, right? He understood English very well, but I was like maybe second, third grade level Russian. So yeah, it was pretty great. And I think that it's that just knowing that it's the assimilation of everything that is you, and recognizing that you're doing exactly what you're meant to be doing with the decisions that you're making, even if it's not in a set path, and you're failing forward in it. Doesn't matter, just keep moving in that direction, and keep the faith in yourself. Don't ever lose faith in yourself.
Definitely, all aspects of ourselves are very much important, and they definitely contribute to being a well-rounded person. So thank you so much for that answer.
So we can move on to the questions from our audience. So our amazing panelists have been answering your questions. So a lot of them are already answered, but I do have one question for you guys. So what inspires you or excites you about the future of STEM in air and space?
Can you say the question one more time?
Yeah, I
Yes.
didn't quite hear it either.
So what inspires you or excites you about the future in STEM in air and space?
For me, something that's exciting is the diversity. Like, I don't think we've scratched the surface in how we solve problems, and at least at NASA, and how we approach problem solving. Because you tend to get a bunch of engineers in the room, and they may have different experience as an engineer, but they're still a bunch of engineers. And now, and maybe Jessica and Pamela, you might have had different experiences being in the fields you're in, but I think at the analysis level, people are beginning to understand the value of bringing in completely different type of fields. I've been working with industrial organizational psychologists, and the dimension they bring of having an understanding of human behavior to how you solve problems is totally different. And so I think it's exciting for me to think about how we can start leveraging other types of fields that maybe we didn't traditionally think of as STEM, and pull them into STEM and problem solve in way more impactful ways. So that's what I'm excited about.
I really loved how you pulled in things from the outside the scope of just STEM. Because I feel like many students are very STEM focused, but sometimes you do have to pull outside of that to succeed.
Okay, I'll go next. I'll say from an industry perspective, and what's going on right now is we've had what we call these incumbencies, these companies that have had long-standing contracts to provide products for 20, 30 years. And it's these major companies like Lockheed Martin. What our customers are doing these days is seeing the new companies, the new entrants that have come in and are really shaking things up. So SpaceX, like I'm sure you guys know about, Blue Origin, these what haven't been considered traditional companies are now becoming very viable companies with very viable products and offerings, and creating a lot more competition for the larger corporations that have been around for many, many years doing both defense work, but also other types of contracts. What that is making happen is putting pressure on these longstanding companies to do is actually think outside the box and become more competitive, bring in that diverse opinion. What I came into even, in the 2010 timeframe was the era of pensions, of employees never leaving the companies that they started at. And so they had the mind frame of, well, this is how we've always done it at this company, and therefore this is the way we do it. That has totally been exploded. Not only do people not have the pensions anymore, so you also have these new generations that get a lot of value out of jumping from company to company and working on different products. All of that in that same environment of competition being driven. We get to, as industry, partner with each other now in new ways, see how other companies are doing things, and become teammates with those other companies, go into products that we would have never gone into before. So I say that all because what you will get to see now if you join a company like Lockheed Martin is that it's not the Lockheed Martin of even 10 years ago. And it's not the products that they were developing even 10 years ago. They're having to think way outside the box, go faster, and try things and take risks that they wouldn't have had to take before. And so us from a STEM perspective, that means getting to do really cool things.
I really love how this change of how things were before promoted a lot of growth. So I feel like originally you wouldn't think that would be the outcome of it. So it was a really nice outcome to hear about.
Unfortunately, that is all we have time for today. We have officially reached the end of our webinar, and I hope that you all have learned a lot from our fabulous panelists about STEM pathways in air and space. Be sure to keep on exploring. We're going to go ahead and add the links for our website, the FabFems website, and our YouTube channel into the chat. Thanks again to everybody for joining us today, and thank you once more to our fabulous panelists. We look forward to seeing you guys all at our next FabFems Friday next Friday, which will be focused on STEM and medical technology. So make sure to watch out for your email and social media for all the links and details. I hope you all have a great weekend. Thank you all.
Thank you.